So we're just going to jump into this and let's get started. So example 1 says if f prime of x is equal to 24 x to the third, then find f of x. So as we know from our Calc 1 class, if we have f prime of x equals 24 x cubed, and we want to find f of x, that's what we call the antiderivative. So this is what would be before we took the derivative. So what is that original function? So we want to find the proper word would be antiderivative. And in my videos, I'm going to shorten a lot of words and not spell them out. Not a great speller, but that is okay. I can get you through the math. So we want to find the antiderivative. That is the proper word that we're going to use. But in non-mathy words, we have a derivative and we want to find the original or starting function. Okay, so we have 24x cubed, and we know that our derivative rule says if I have f of x equals x to the n, then f prime of x is n times x to the n minus 1. That's just our basic derivative rule. So now we're going to go backwards. We have this original function. So here we have n minus 1. So our 3 here is really n minus 1. So we want that x to be n. So I'm going to add 1 to it. So 3 plus 1 really gives us 4. So we have x to the 4th. And what's nice is I have an eraser. So I can kind of erase here and I can say, actually, 3 plus 1. I'm going to come down here and write our final answer. X to the 4th. Up here can just be our scratch work. And so we added 1. And here normally we bring this n down. We think of bringing that n down and subtracting 1. Well, if I'm undoing that, so think about if we undo subtraction, we do it with addition. And in this case, we're undoing a multiplication. And so we want to divide. Now, here we would multiply by our n to go from our original function to our derivative. And so now, if I want to go from that derivative to my original function, I'm just going to bring this 24 up just as a constant, just because when we take derivatives, we do that. So now I'm going to divide instead of multiply, because division is the inverse of multiplication. So I'm undoing that multiplication. In basic terms, I'm undoing it. So I'm going to divide. And so here we brought down our original. So let's see. We have the option of dividing by 3 or 4. Let's divide by 3 just to kind of check this out. So don't write this down. Don't write this down right here. This is the wrong answer, and we'll kind of see why. 24 divided by 3 is 8. So I'm just going to leave it as 24 over 3. Let's say that was our final answer. Again, don't write this down. if I were to take the derivative, this is how we would check it. We'd bring this down and we'd have 4 times 24 x cubed divided by 3. Hey, those don't cancel. That's not right. So let's try it with our 4. Instead of 3, let's try dividing by 4. So we have 24x to the 4th divided by 4. So let's try that. So f prime of x, let's just check our work. We bring down this 4. And so we have 4 times 24 x cubed divided by 4. These would cancel and leave us with 24x cubed. So that's what we were looking for. That was our derivative. So that means our original function, is 24x to the 4th divided by 4. Now, I'm going to leave it like that for right now. And we'll talk about an issue with this problem. So, definition, a function is an antiderivative of f of x, provided that the derivative equals f of x. So what this is saying is that f of x, capital F of x, is the antiderivative of f of x. So we're saying our derivative is little f of x. It just makes notation a little bit easier. So in order, we would have capital F of x, little f of x, which is the derivative. And then if we took the derivative again, we'd have f prime of x. So these are all taking a derivative down and going back up, we're taking antiderivatives. Okay, so what I want you guys to do is pause the video and do example 2. So I want you to find the antiderivative. Go ahead and pause the video and do that. Welcome back, guys. Hopefully you found the antiderivative to f of x equals 10 times x to the 5th. Now we are going to do this one together. So our original function, f of x equals 10x to the 5th, and we want to find the antiderivative. So we want to find capital F of x. So as we learned above, we add 1 to our number, to our power. So our power is 5. So we're going to have x to the 6th. That 10 is just a constant. So just like in derivatives, when you take a derivative, those constants stick around. That constant is going to stick around. And what we learned in the first problem was when we added the power to undo that multiplication that we would really do in derivatives, we divide by that number. So we are going to divide by 6. And I am not going to reduce this. If you want to reduce this, you can. That's up to you. That's up to you guys. All right. So now let's check our work. I am just going to draw a line here. And so let's check work. If f of x is 10x to the 6th over 6, f prime of x, let's take the derivative, that 6 comes down, so I have 6 times 10, we subtract 1 off of there to the 5th, divided by 6, the 6's cancel, so f prime of x is 10x to the 5th. Beautiful. I have a question for you guys. what if my original function was plus 7? Just randomly thinking of a number. When I took its derivative, the derivative of just a number is 0. I would have plus 0. And I'd still get that same answer. What if that number was 50? Hey, this still works out. So no matter what number I put here, as long as it's a constant, then that number goes away. So I have all of these answers that could be my antiderivative. So what we do in Calc 2, or any calculus, what we do to kind of cope for that number that could be there, we don't know. We add a plus C to our end of this. You guys are going to get sick and tired of me saying plus C on all of our answers. So what that really means is our first answer was wrong. Well, partially wrong. So our final answer we said was 24x to the fourth divided by 4. But we have to worry about that constant. So I'm going to say plus C. I'm going to add that plus C in there. All right. So we have all of this work. We have our answer, our final answer. Let's circle it just so you guys know. Whoa, that was way bigger than I expected. So you guys know where we're looking. Okay. This is where I would pause the video and ask if there's any questions. Feel free to leave feedback in the comments. See if you have any questions. I can answer them. Or if you're in the class, feel free to upload it in the discussion box or just send me an email. I am fine with answering emails, questions after. All right, so let's move along to page 2. And now we have this definition. The indefinite integral of f of x, where the most general antiderivative is the integral of f of x dx, is f of x plus c, where c is a constant. I will say plus c that way all the time. Okay, so now we're looking at some new notation. Before, I wrote out all these words. If f of x is this, then find capital F of x. That is a lot more words than any mathematician wants to use. If you notice, most of our problems say solve, and it gives you a problem. So this has a lot more words in it. Mathematicians are, all the ones I have met, are inherently lazy, but not in showing their work and doing the work and putting work into it, but in the fact that if they can get away with using less words, they're going to do it. I've seen proofs where it was mostly symbols. So the phrase I'm going to use for the rest of my videos are mathematicians are lazy. So the indefinite integral, let's unpack some of this. This symbol right here, what that is telling us is saying find f of x. So, or find whatever function is in here, right here, saying f of x. So we call this symbol the integral. That symbol highlighted in blue is the integral. And right here, we call it indefinite because there's no little numbers attached to it. We'll see those in our next lesson. This lesson is going to be consisted of 2 videos, but our next topic of discussion is definite integrals, and so you'll kind of see the difference. But that symbol itself is an integral or an integrand. And so when I put an integral of a function, I'm saying find the antiderivative for me. And that's what this top part is saying, the indefinite integral right here of f of x, so of the function, whatever function is here, let's put some different colors to it, of f of x is the most general antiderivative. So we said the antiderivative was capital F of x. And what we learned in the last problem is we need that plus c just to cover any constant that might be hanging around that we don't know about. Okay, so example 3 says evaluate the following indefinite integrals. And so we just have a bunch of indefinite integrals to kind of go through. All right, so this first one, I'm going to let you guys pause the video and work it. So pause the video now. All right, welcome back. This is just finding the antiderivative. And so when we work this, we have, I always like to rewrite my problems, 3x to the negative 2 dx. And I did not go over that little dx before, but this is just saying with respect to x. So remember when we were talking about derivatives, it's saying this derivative was taken in respect to x. You're probably going to think in Calc 2, all through Calc 2, this is silly, this dx doesn't matter, and you're going to forget it. If you're my student and you miss it, you're going to get a point off for notation. Just telling you now. Because it's telling you this derivative was taken with respect to x, so you're going to take the antiderivative with respect to x. When you hit Calc 3, you're going to have x's, y's, and z's, and all sorts of different letters and symbols, and you need to know what to take it with respect to. It is very, very important, although right now it seems useless. Okay, so here's our power rule stated over here. We take x to the n plus 1 divided by n plus 1 plus c. So I'm going to add 1, and I get 3x to the negative 1 divided by the same number, so divided by negative 1 plus c. If you want to simplify this, you can. You don't have to. So negative 3 over x plus c. Okay, so in my videos, I might not always explain some algebraic rule. If in class, what I would do if anybody got stuck, confused, or a little lost, I would go over these, but because this is a video, I'm just going to keep going. If you have a question on any algebra stuff and you're in my class, please, 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 please email me. I don't want you to get behind in Calc 2 because your algebra might be a little rusty from taking a break or whatever reason. All right, so this is our final answer. Negative 3 divided by x plus c. Okay. So let's look at these basic integral rules. Number 1, we've already been doing. If there is a constant on the inside of that integral, we can bring it out. We've kind of just been treating it like it's just there so far. But it's just a constant. It just comes along for the ride. You can bring it out and just integrate your f of x. The other ones says if we have functions that are added together, we can just separate them as one function with a integral of one function dx plus the other function, the integral of the other function dx. Same thing with subtraction. If I have two functions being subtracted from each other, we can say our first function minus our second function. All right, so let's do this example together. And I'm going to use all of these rules very kind of overly use them, and then I will have you work on this one by yourselves. But then when I do it, I'm going to just use the more relaxed rules, which is perfectly okay on the exam. Okay. So if I was to use these rules overly too much, just use them too much, what we can do is notice that I have 15x to the 5th plus x cubed over 8 plus 12. I'm going to break those up into 3 different integrals. The integral of 15x to the 5th dx plus the integral of x cubed over 8 dx plus the integral of 12 dx. Now, notice each one has an integral and a dx. Integral, dx, integral, dx. We had addition here, so I separate them all by addition, and now the constants can come out. Again, I'm just kind of using these rules a little too much or exaggerated, just so you can kind of see how these rules work. So I'm going to bring the 15, the integral of x to the 5th dx plus 1/8, the integral of x cubed dx plus, you can leave 12 in there, you can bring 12 out. That's up to you. I'm just going to leave it in there. I don't have an x to kind of have a placeholder, and it seems silly to bring the 12 out and just leave the 1. Because it does not go away if I bring the 12 out. So just for funsies, if you decided to bring the 12 out, you would have 12, the integral of 1 dx. There's a 1 as a placeholder. To me, that feels really funny. So I'm going to do the integral of 12. Oh, no x. 12 dx. Okay. Now I have used all my fun rules. I have separated everything, over exaggerating. So now I'm going to actually take the antiderivative of each of these. So I have 15x to the 6th divided by 6 plus 1/8 x to the 4th divided by 4 plus 12. Ooh, what does 12 need? So let's look over here. Our derivative, just kind of side work, of 12 is 0. So that's not 12. That's not what we want. What happens if we did 12x? The derivative of 12x is 12. So since we're finding antiderivatives, when we have just a constant, we're going to tack on an x. Okay, we took all these derivatives. Now we need to do plus c. And I'm sure I'm going to simplify this and then I'm going to answer that question. So we have 15 over 6, x to the 6th, plus 1 over 32, x to the 4th, plus 12x, plus c. And this is our final answer. Okay, one question that I get all the time when I do these is, Katie, don't each of these need a constant? Sure, we can do that. So I'm going to do plus c1, plus c2, plus c3. But the thing is, if I get all of these together, if I do c1 plus c2 plus c3, a constant plus a constant plus a constant is still a constant. So I can just tack on plus c at the very, very end. And we don't need all these individual constants. All right. So go ahead, we have the rules over here, and pause this video and try example A. I will say that you probably need to switch this to a power instead of root notation. All right, go ahead and try this. All right, welcome back. Hopefully you were able to solve this. And if not, that is okay. So I'm going to not use the over-exaggerated notation that I was using before, just because that's not what we use day to day. If you look at someone's work, they're not going to use that. So I am going to rewrite this. We have the integral of 4. Notice this x is on the bottom, so let's look at 1 over x to the 2. Remember from algebra that this is really x to the negative 2. We can move a number across the division line if we change its power to a negative. If you have more questions than that, please email me. This is x to the negative 2 plus 5. And remember from algebra that the cubed root of x is really just x to the 1/3. I do have videos on all of these things. If you're struggling with some of these little algebra rules, just let me know and I can upload those as well. So this is 5x to the 1/3 dx. So first I'm going to rewrite it. I'm going to make it more easy to use these power rules. So the power rule works when things are powers, not roots, not in the bottom part of a division. So we are using some algebra tricks to rewrite. Okay, so now we can take the antiderivative. So the 4 just tags along. X, we're going to add 1. And guys, feel free to do this in your calculator. I am notorious for doing -2 plus 1 in my calculator, especially on a test, because my brain does not like to compute this. So -2 plus 1 is -1. The most answers I see are -3. So use your calculator. Divided by -1 plus 5 x 1/3 plus 1. Again, you can use it in your calculator. You get, I'm going to bring my calculator up. Okay. Maybe. For my students, you will be able to use the TI-84. Okay. I'm just going to leave this off to the side in case we need it again. So 1/3 plus 1 is 1.333. I'm not going to do decimals, so I'm going to hit math. And frac comes up. And we get 4/3. So x to the 4/3. And now I'm going to divide by 4/3. Okay. And I do want you guys to remember from algebra. I know I keep saying, remember from algebra, remember from algebra. I'm going to come off to the side. And if I divide by a fraction, like 4/3, that this is really 3/4. So again, you can do that in your calculator. 1 divided by 4/3 is 0.75. So math, fraction, 3/4. Okay, so going back over here, I have -4 x to the -1 plus 3 times 5 over 4 x to the 4/3. One more simplification. So -4 x to the -1 plus 15 over 4 x to the 4/3. And we are done. And I did not mean to draw that top line through my 4. Okay. So, oh, what did I forget? I've been forgetting it this whole time. Plus C, plus C, plus C. If I had done that on my test, I would have gotten -1 for notation. As you can see, these -1s for notations can build up. So don't forget them. Even I forget them sometimes. As you can see, I forget my C. All right. So that one was a little harder. First, we had to do some algebra manipulation. Then we find the antiderivative. Find antiderivatives. And the rest is just algebra simplification. You can do 4 divided by -1 in your calculator. 4 divided by -1. You get -4. I could have just typed this in my calculator. So 5 divided by 4 divided by 3. And I get a number. That's not a helpful number. And so to turn it into a fraction, if you hit the math key, it's the key that just turned red. Number 1 is frac, which means fraction. I'm just going to hit enter, and you'll see my answer is going to turn into a fraction. Then I hit enter again, and we get 15/4. Through this class, I'll be teaching TI 84 plus tricks, techniques, all those little things. Sometimes if I go too fast, just let me know. I try to show these slower, especially when we get to the more complex things. On my test, you are allowed to use a TI 84 plus. I know if you're an engineering student and you're trying to do this, you're probably working with the TI 36 Pro. Your calculator can still do these. Anything in a Calc 2 class that the TI 84 Plus can do, the TI 36 Pro can also do. I don't have an emulator for that. I can't find one. If you guys find me one, if you make me one, I will gladly use it. And I will show both. Because if you're a math major, you're going to be using this calculator. If you're a biology major, most likely this calculator. Engineering students have a different calculator. All right, so let's work on this one. We have 25x plus 5x to the -1 dx. And so now we want to find the antiderivative of it. So let's just go about this. So I'm just going to rewrite the problem. 25x plus 5x to the -1 dx. I'm going to do this, and I'm going to do it incorrectly. You're probably saying, Katie, how can you do this incorrectly? You'll see. So don't write this down. This is 25x squared divided by 2 plus 5x to the 0 divided by 0 plus c. Oh, that's an issue. Hopefully you're screaming at your computer at me and saying, Katie, you can't divide by 0. The world's going to explode. You're right. So while this first antiderivative is correct, the second one, that can't possibly be, because we cannot divide by 0. Okay, let's go check our rules. So this works for n not 1, or n, or -1, excuse me. Our n is -1, so our rule doesn't work. So we have to think of something. What derivative gives me x to the -1? It's obviously not x to the 0, because that doesn't work. So let's go over here. Let's check. Let's check some things. Let's do, what is the derivative of ln of x? Hey, That's 1 over x. Now let's see. If I take the integrals of these, the integral and the derivative cancel out. So ln of x equals the integral of 1 over x dx. So if we see, or let's do a little algebra, ln of x equals the integral of x to the negative 1 dx. Whoa, not quite sure what happened there. So if we see x to negative 1, then we know our antiderivative was ln of x. Doing like I did before, instead of using kind of this proofy technique, we want to say, okay, what derivative gives us x to the negative 1? Or 1 over x. So that requires knowing Calc 1 a little bit better, but we know the derivative of ln of x gives us this. So my antiderivative of 1 over x is ln of x. Kind of likely using that approach better. So we're going to erase this. I'm erasing. You guys didn't write it. Now you guys can write this down. We see 5x to the negative 1. And so this is 5 ln of x plus c. Okay, if you're working on my open math, they may require a capital ln of x or lowercase ln of x. It's kind of picky. Sometimes it'll tell you in the problem. All right, so all of these problems are really just kind of coming up with what function gives me this derivative. So we're undoing Calc 1, which makes me really excited because it's like a little puzzle and we're trying to undo it. You guys might not be very excited about it, but I find it very exciting. All right. So we're going to do this last problem. It's using some algebra. If you want to pause the video and try it, go for it. If you're just like, Katie, I'm done, I just want to see it, let's do this together. So first, there's a division here. None of our rules that we've talked about or even looked at says what derivatives gives us this. When I see this, my brain's like, I don't know a derivative offhand. If you do, you're better than I am. So let's use some algebra and rewrite this. So remember from algebra that if we have something dividing the whole thing, it can divide each function separately. So we're going to write 2x cubed over x minus 6x divided by x plus 9 over x dx. All right. So we separated it. I still don't know what the antiderivative of 2x cubed over x is. 9 over x, we know that's ln. That's going to be an ln. But what in the world? Hey, we know that's division, right? So x cubed divided by x. I have time to do a little algebra here. That's like saying x times x times x divided by an x, where 1 cancels out. So that leaves us with x squared. So the integral of 2x squared, because that cancels, minus 6, because the x's just cancel, plus 9. I really don't like having that x in the bottom. You guys can leave it there if you want to, but I'm going to bring it up to x to the negative 1 dx. Okay, now each of these is something that I can integrate. If I was to use the rules, we would have 2 integral of x squared dx minus the integral of 6 plus, dx plus 9 integral of x to the negative 1 dx. And I can integrate but each of these separately. So 2x cubed divided by 3 minus 6. Remember, if it's alone, we're going to tack on an x. Plus, sorry about that, guys. Plus 9. If we see an x to the negative 1, your brain should be screaming ln of x, ln of x, ln of x. So this is ln of x plus c. Okay, that is our answer. I'm just going to rewrite it to make it a little nicer. So 2/3 x cubed minus 6x plus 9 ln of x plus c. Final answer. Okay, so what I would want to do is down here, I just want to write a few rules. If we have the integral of a constant dx, we know that that's cx. Uh-oh, let's use a different constant, c1. So we just tack on an x plus our constant, our normal constant. That might be a little confusing. So if it was the integral of 5 dx, it would be 5x plus c. Maybe it's a little bit better with an example. So 5 dx, we get 5x plus c. The other thing I want to mention, we have the integral of x to the negative 1 dx, which equals the integral of 1 over x dx. This is ln of x plus c. Okay, these are not things you have to memorize, but these are things I want to point out that are slightly different. And slightly different meaning they just don't follow those power rules like we want them to. They're still antiderivatives. So when you're looking at this, you want to think to yourself, what is this? That's actually a wonderful, wonderful, wonderful test question, is what is the integral of f of x ds asking for? What is this? What am I doing? I'm adding one, I'm dividing it. I can do this all day long, but what is it asking for? And that's what I really care about. So what you'll find about me through this entire course is that I'm curious is what is this what is this question asking for? What are you actually doing? I don't want you to become a computer and be able to just find the antiderivative, but what is it asking for? So it is asking, what is the antiderivative of f of x? So if it's something you can't solve off the top of your head, you need to ask yourself, do I know this as an antiderivative? Do I know this as a derivative? So this piece is a derivative, and I'm asking, that integral tells me you're asking for the antiderivative. Okay, so test question, you'll see it soon. All right, guys, I hope you enjoyed this video. If you have any questions at all, please, 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 please email me or put a comment in the comment section or ask through Canvas. All right, I will talk to you guys later.